Here's the next question, number 28. The circuit in the figure shows a full wave rectifier. The input voltage is 230 volts RMS single phase AC. The peak reverse voltage across the diodes D1 and D2 is. Now the four options say 100 root 2, B gives 100 volts, C 50 root 2 and D is 50 volts. Now in order to solve this problem, we first have to understand what the peak reverse voltage is. The peak reverse voltage. Now the peak reverse voltage, also known as the peak inverse voltage or PIV, is the maximum possible voltage across a diode. So this actually happens when it is in reverse bias. So it is the maximum possible voltage across a diode in reverse bias. So if you notice the diagram over here, we have our primary and secondary. You will see that the full wave rectifier here, the rating has been described over here, 230 volts by 50, 0, 50 volts, center tapped, right? So during the first half cycle of the supply, the top of the transformer secondary winding is positive. So what happens is the diode D1 starts to conduct. It is in forward bias. So this provides almost zero resistance because it is in forward bias. The entire voltage of the upper half winding is developed across this load here. Let's call this RL. Okay? So now the voltage across the non-conducting diode D2, this is in reverse bias. So PIV is the maximum voltage across the non-conducting diode in reverse bias. So in reverse bias what happens is the voltage here, the voltage at D2 is the sum of the voltage across, sum of the voltage, the sum of the voltage across the non-conducting diode D2, the sum of the voltage across the transformer secondary and the voltage across the load resistance RL. Across the load RL. So what this actually means is that PIV of D1 and D2, they will both be the same because at one half cycle one is D1 is in forward bias while D2 is reverse bias, and then in the next half cycle they interchange that way. So PIV would be the sum of the voltage across the transformer secondary, which is VM, maximum voltage, plus the voltage across the load RL would be VM again. So PIV is equal to 2VM. Let me just grab another sheet of paper and we'll continue to the next step. So far we have PIV of D1 is equal to the PIV of D2, which is equal to 2VM, right? Okay, so in the question over here we have been given the RMS value, 230 volts RMS is given. So in order to find the peak value, we know the formula that V peak or VM is equal to V RMS times root 2. This is the formula. So if we have to write the PIV in terms of V RMS, what happens over here? We get 2 VM becomes 2 into V RMS times root 2. Now, according to the diagram over here, notice that what is the voltage across the secondary? It is 50 volts, right? So 50 volts is the V RMS. Now let's substitute that over here. What happens? Let's see, that's 2 times 50 root 2, which is 100 root 2 volts. So the answer over here is 100 root 2 volts, and that matches with option A. So this is the solution, and I hope it has helped.